So here is the question. A material having an index of refraction of 1.3 is used as an anti-reflective coating on a piece of glass with n equals to 1. What should the minimum thickness of this film be to minimize the reflection of 500 nanometer light? Now notice that this question is related to one of the topic which is about interference in films. Oh yeah, by the way, my name is Kamal Hakim bin Zaki with metric number 20934. So how do we solve this question? First of all, let's draw a diagram. Mana diagram? Ni dia. Okay, let me get this thing big. So this is the diagram to show how the situation goes. Now, as we can see here, this is anti-reflective coating with n index 1.3 and this is the piece of glass with n equals to 1.5. Now, let's say the light goes through the air and goes to the top of the surface and at this point on the coating. Now whenever the light or wave travels from the material to another material with different density, there is a phenomena called as refraction. As we can see here, the red line, which is the light comes from the air, is as it goes down, it gets reflected. Now since the n here is greater than, I forgot to put that. Now, since the n here is greater than the n here, then the light will be bent and becomes closer to the normal line here. Now, as the blue line here, as it goes further down here, notice that it will get reflected again, since the n here is greater than n here. But in the same time, there is also a phenomena called as reflection. The light will be reflected from the surface at this surface on material, but the light reflected but not that much. Now let's get into theory. Lloyd's mirror experiment shows that the light will experience a phase change upon reflection on the surface, totally 180 degree. So the scientist has made the theory an electromagnetic wave will undergo a phase change of 180 degree upon reflection from a medium that has a greater index of refraction than the one in which the wave is traveling. So here, notice that at this point, the light get refracted. Notice also, both of these points, the light get reflected and undergoes a 180 degree phase change. Since you look here, n is greater than this and n here is greater than this. So, the light will undergoes no phase change if the n at the bottom here is lower than n in here. So notice that here and here at this point. Now notice that at these both points they experience the same phase change, which is 180 degree. And what does it means that we will gonna have a constructive interference. So we understand how the situation goes. So let's find the answer for this question. Now since this is the constructive interference of light, so the condition for the formula should be like this: m plus half lambda. So the n here is the index of refraction in the middle between the top and the bottom. T here is the thickness of this thin film. M is an integer multiple. It can be 1, 2, 3, 4, 5, 6 and so on. But since the question asks us to find the minimum thickness, so the value here should be 0. And notice that the lambda is the wavelength of light. So we know all the information. Now let's apply all the information into the formula. Oh yeah, notice that here we want to convert a nanometer into meter. So we write the value should be like this. So the value should be like this. 500 and darab 10 negatif ke 9. So the answer is 96.2 nanometer. Now notice that we did not use this n equals to 1.5 in the formula, but it helps us a lot to determine whether the light is experiencing the constructive or destructive interference. So what if the light is facing destructive interference? So what the formula should be? It should be 2n t plus equals to m lambda. So this is the formula for the destructive interference. But in our case, the light is experiencing the constructive interference. So this is how you solve the question.